your complete React hooks crash course. So in this crash course, you're going to learn about what hooks even are, what state hooks are, how you can use context hooks, ref hooks, effect hooks, performance hooks, custom hooks, and much more. So this is going to get you started with using hooks within React. Now, quick housekeeping note before we start. I've created this website here for this crash course in which if you want to access this and if you want to follow along, you can go to my GitHub, code Ryan Solomon /React-hooks-crash-course, and then you could clone this repo here and then just run npm run dev within your terminal and kind of get this project up and running. I'm going to also be using this project within VS Code to go over different examples of using the useEffect hook, useCallback, use local storage, creating our own custom hooks, and different things like that as we go. So I would definitely recommend you following along and playing around with these different hooks to get a better understanding as we go here. But to start us out, React hooks are just JavaScript functions that allow you to hook into built-in React features like state management, context, effects, etc. So React has built-in features to help allow you manage things like state. They have built-in features that help you create side effects in your application. So like if you needed to use local storage or make network requests or anything external to your application, you can do that using built-in hooks within React, and also using things like context. So sharing information across your application, that can be done using context, and React gives you different hooks to hook into these React features. And these hooks are just JavaScript functions that allow you to do that. Now you can even create your own custom hooks. And often your custom hooks will be very similar to just creating a JavaScript function, but they will kind of wrap around some of React's built-in hooks. So for example, React has a hook called useEffect, and you might create your own custom hook that uses the React useEffect hook to bundle up some React logic and then reuse that across your application just how you would a JavaScript function. Now, there are a few rules of hooks that you should keep in mind. And the first rule is that hooks are prefixed with use. So within React, you'll see hooks that are called like useEffect, useState, useReducer, useContext, useMemo. They are prefixed with the word use, and this is going to be lowercase use. Also, they can only be called within React components or custom hooks. So you cannot call a React hook in just a plain old normal JavaScript file. It must be called in either a React component or another hook. Now, they also must be called at the top level of those React components or hooks. They cannot be called conditionally. So React needs to know the order in which your hooks are called. So within this homepage component here within my React app, and this is technically a Next.js app, but it uses React. So within this homepage component, I would call my hook const state equals useState. This is a React hook that we'll talk about in just a second. I would need to call this hook at the very top level of this function here. I wouldn't be able to do like if some condition, then const state equals useState. If I do that, that's actually going to be an error because I can't call hooks conditionally. I need to call it at the top level of a component or another React hook. Now, React provides several hooks, like I mentioned earlier, that can be used for state management, that can be used for context, refs, effects, performance, and more. And like I mentioned, you can create your own. So hopefully that gives you a good idea of what React hooks are and some different rules of hooks. But now let's start to dive into some of the built-in hooks of React, and then we'll get to some custom hooks here later on. So let's first start with state hooks. And React provides two hooks for managing state within your applications, useState and useReducer. So I've created this like component here. It's just a watch wish list, and I'm kind of into watches, so I felt like this is more interesting to me than a normal like to-do list or something like that. So when I'm talking about state, what I'm talking about is some information that is going to be displayed to the user. So like, for example, we have this input here, and we should be able to type into this input, and then I should be able to kind of submit this input, and then it should add a watch to this list with a watch title, and then I should be able to remove the watch, clear the watches, and this data that shows up to the user that changes over time is state. State is just information that you want to show the user that also changes over time. For example, the current state of my application right now is this watch list that has 3 different watches. But if I cleared this, the current state of my application will be 0 watches. And in this instance, the state is the watches that are showing on this page. It is the data that is changing over time. So to manage that state, React gives us the useState and useReducer hook. So let's go access this component and hook it up to useState first to show you how this hook works. So let's go back to my application here. Let's go to my state hooks page.jsx, and you can see I'm rendering a component called watch list. So if I go to my components here and I go to watch list, you see that I have a very just basic component here that I have an input for adding a watch. And then right now I'm just rendering out a list with just a few different list items, but we need to actually like hook this up to state so the user can type into this input and then actually add these different watches here. So what we're going to do here is I'm going to say const watches, comma, set watches is equal to useState. And I need to import useState from React because this is a React feature that I'm hooking into. Now this useState hook, when we call this hook, it is going to take our initial state as an argument. So initially, I just want our state to be an empty array of watches. I'm not going to initialize the state with anything, but if when your page first loads, if you want to initialize your state with like a couple of watches in them, then you could add, object within your array that has a title for your watch title. So like Rolex, and then something else within it if you wanted more information within your watch state here. But with this, I just want it to be an empty array. And when we call useState, it returns an array of 2 elements. The first element is going to be your current state. So my current list of watches. And then the second element is going to be a way to set the state or a way to update the state. So if I want to add watches, I would call this second element returned from useState. So since this returns an array here, you'll commonly see individuals destructure this automatically with this syntax right here. But this would be the same thing as doing something like const state is equal to useState and calling this. And then you could say const cur state is equal to state at element 0, and then const set state is equal to state at element 1. That would be effectively the same thing as just destructuring these values immediately when calling useState. So that's all we're doing here is destructuring the current state, which I'm calling watches, as well as the state setter, which I'm calling set watches. So first off, within my input here, I'm going to actually need to add a button here that is going to just say add watch. And yeah, I'm not really focused on the styling here, so this might look a little gross, but for my on click, I'm going to pass a function that is going to add a watch. So now I'm going to create a function here that is called function add watch. And what I'm going to do is I am going to call the set watches. And when I call this, what you need to be aware of is that if I just called this with, let's say I just wanted to add a new watch here, well, I would erase all of my current watches. Like I just want to do an add to my list. I don't want to just replace all my watches and add one single new watch. Like I want to continuously add to my list. So when calling set watches here, since I want to add to my previous watch state, what I need to do is when I call this function, I can actually pass a function to this set watches function. And when passing a function to this, it's automatically going to pass the previous state. So I can say prev watches, and then I'm passing in a function, and then I can return my new watches. So I'm going to return an array that contains all of my previous watches. So I'm going to spread those into this new array, but then I need to add a new watch. And every new watch I'm going to add, it's going to be an object that has a title, and that title, well, that should be my input text, whatever this text is here. So I actually need to add state for that as well. So I'm going to set my title to input text here, but now I need to create that state. So I'm going to say const input text, comma, set input text is equal to useState, and I'm going to initialize it with just an empty string here. But now for my input, I'm going to set my value is going to be my input text. And when I have a change event occur, so on change, I'm going to accept the event, and then I'm going to set my input text to my event dot target dot value. So I'm now making this a controlled component here because I'm managing this component's value with state. And when this input changes, I'm going to set my input text to whatever the user types as the input. And then when I click add watch here, it's going to call this add watch function, and I should set my watch state with all of my previous watches, but I'm then going to add my new watch with the title of input text. Now I'm also going to want to add an ID here, which is going to help me remove watches here in the future. So I'm going to add ID, and here you wouldn't necessarily want to do this. You would want to add like a unique user ID, like a UUID, or you could use the use ID hook that you can actually use built into React. But for now, for simplicity, I'm going to just do the old trick of math.random and give it a random number as an ID here. Now, instead of just rendering out these different list items here, what I'm going to do is I'm going to map over my watches to render out list items based on my watches. So I'm going to call watches.map, pass in every watch to this function, and then I'm going to return a list item that has my watch.title, and then as a key to my list item, I'm going to do watch.id. So let's go back to my page here, and you can see I have my watch wish list. I have my add watch label for this input, and then when I click add watch, it should add a watch here. Now, let's just to make sure that this looks a little bit less gross to this div here, let's do style, and then I'm going to just add a little bit of margin, let's say 20 pixels, 0 pixels, and see if that looks a little bit better to spread that out, and it does. So what I'm going to do is I'm going to add a Rolex GMT Master 2. And when I click add watch, you see this now adds a watch to my list, because when I clicked on add watch, it called set watches, and it took all of my previous watches and added in a new watch here, and it added a watch to this watches list. And then I map over that list and I render out a watch for that list. But you can see it didn't clear my input. So after I call my add watch function, I also need to make sure to call my set input text and to just set that back to an empty string after adding a watch. So now I added my GMT Master 2. So now let's add a Rolex Daytona, and it adds another watch to my list here, and it also clears this input like I want. Now, what if I forgot to spread in all of my previous watches? Well, what you're going to see here is if I do that, I just try to add a new watch here. So like a Rolex Submariner is another watch. It clears my list and just adds the Submariner. And if I add a Daytona, you see it just adds the Daytona. So it's not spreading all of my previous watches into this list. So we need to make sure to do that. Now, what we also need to do is I want to add a way to remove my watches. So to do this, what I can do is I can just add a button within this list item, and I'm going to just put in X, and that's going to allow me to remove my watches. And on click, I'm going to call a function here that is going to call another function, and it's going to be remove watch. But I'm going to call that function with my watch.id. So let's create function remove watch, and it's going to accept an ID. What this is going to do is it's going to set my watches, but I need to use my previous watch state here to set my watches. So I'm going to pass a function of prev watches. And if I didn't want to use my previous state when setting my state, I could just set state here to, title, whatever, and that's going to set my state to whatever I pass in here. But since I want to set my state based on previous state, I'm going to pass in a function that takes my prev watches. And then what I want to return here is I want to return my prev watches dot filter, and then it's going to take a watch, and I want to say my watch dot ID does not equal the ID that I pass into this function here. And by doing this, I'm going to filter in the watches that don't match the pass.id, which is effectively going to remove whatever watch that I click on this X button here. So let's go ahead and see this working in action here. So I'm going to add a couple more watches. So let's add the sub, and let's add a day date here, the presidential. So now that I've added these watches, I should be able to click this X, and it should just remove the Daytona. And it does. So you can see we are now successfully removing watches from our state here. Now, moving forward with this, we also want to be able to click this clear button and clear all of our watches. So to do this, what we can do is for my clear watches button down here, I can add an on click, and that is just going to call a clear watches function. And then I'm going to say function clear watches, and all this needs to do is set my watches, but I'm just going to set it to another empty array here. So it's going to just set my state to an empty array, which is effectively going to clear my state. So let's add some more Daytona. Let's do GMT. And now that I have these, I can click clear watches, and that does indeed clear my state. So that is how the useState hook works to manage state within your React apps. But now let's look at how does useReducer work? Well, it works pretty similarly to useState, but useReducer is helpful when you need to manage more complex state. So I'll lean towards using useReducer when I need to manage the state of like a form or something like that. Like when you need to manage more complex state, but state that is all related. So within a form, you have like maybe an email, an address, a name. All the state is related to whatever user that you're typing in that form. So when you submit that form, you might want to add all that data to your database. So to manage that state of that form, well, you could, within React, you can see here, like you can add as many pieces of state to a component as you want. So like I can have my watch state, my input state, I could have like, address state and name state for a form if I was doing that. But what you can also do here is you can use a reducer, and that helps you manage more complex state. So right now we're using useState, but let's actually transform this to use useReducer here. So instead of calling useState here, I'm going to call useReducer. And we also need to import that from React. Now, the way that useReducer works is when I call useReducer, the first argument is going to be a reducer. So I'm going to pass in a reducer, and my second argument is going to be my initial state. So that is just going to be an empty array. Now, what is this reducer? Well, a reducer is just going to be a function that you create. So I'm going to create a function called reducer. This doesn't need to be called reducer. You could call this like, watch reducer or something like that. A reducer is basically just a function that takes multiple things and outputs one single thing. And in this case, this reducer function is going to take multiple arguments here. And these arguments are going to be our previous state, as well as some action that occurs. And it's going to take those arguments and it's going to return one new piece of state. So it's taking multiple things and just outputting one piece of state. Just like how in JavaScript, you can use a array.reduce, and it takes all those elements of an array and it reduces them down to one output. So if you have an array of numbers, you can call reduce on that array of numbers to output the sum of that array. It takes multiple things and outputs one thing. And this reducer function here, what it's going to take is it's going to take the previous state as well as an action. And then based on your previous state and an action, it is going to decide what it should output as the new state. And your useReducer function, it's going to return your current state. So just like what it did before, it's going to return an array of 2 elements. It's going to return your current state, but instead of just a state setter, it's going to return a dispatch function. So I'm going to call this dispatch. And this dispatch function, what it's going to do is it's going to allow you to dispatch an action. And it's going to dispatch that action to this reducer as your second argument, which is action. So what we're going to do here is within the body of this reducer, we're going to return new state based on what action is taken. So I'm going to say if my action, and typically an action usually has different properties. Usually your action is going to be an object that has these different properties. And one property that your action usually has is an action.type. Now this is just convention. It doesn't necessarily need to be this, but I would definitely recommend using some consistent convention for your actions throughout your application. But for us, we're going to dispatch an action that is an object that has a certain type to it. So if action.type is equal to add_watch, and a good convention here is instead of hard coding this, you could have a constant called action types, and then that could be an object, and then one property of this object is going to be add_watch, and that is going to be equal to add_watch. And then another action type that we're going to have is remove watch with remove watch as a string. And then we're also going to have clear watches and then clear watches as a string. So if action type is equal to, instead of hard coding add watch, we can do action type dot add watch. And then if that is true, what we need to return is our new state. So we're then going to return our previous state, but then we're going to add a new watch. So what is our new watch going to be? Well, within our action, we need to send a payload that contains our new watch. So I'm going to just say, we're going to add our action.payload. And what this is going to be is the object representing our new watch here. So what we're going to do here is we're just going to implement this add watch portion. So to do this, I need to now dispatch an action of add watch here when my add button is clicked. So for my add watch, when calling this add watch function, instead of doing this set watches right here, what I'm going to actually do is I'm going to dispatch an object that is representing my action. So I'm dispatching this action right here. So this should be an object that has a type Well, my type is going to be action type dot add watch. And then my payload, well, my payload should represent my new watch. So this is going to be an object that has a title, and that title is going to be my input text. And then it should also have an ID that is math.random. So when I call add watch, instead of just setting my state, I'm now dispatching the action to my reducer function here that is going to be used to add a watch, because it's going to have an action type of add watch. And then I'm going to send it a payload that is my watch, that is an object that has my title and my ID. And that is going to return, this reducer is going to return my new state. It's going to return an array that has all of my previous state, all of my previous watches, as well as my action.payload, this new watch right here. I also have my remove watch function here, but I'm just going to comment out my set watches here because I don't have my set watches function anymore. So I'm going to comment those out, and this should allow us to still add a watch here. So let's come back, and if I add a Rolex Daytona here, and I click add watch, you see it doesn't need add watch. And if I do Rolex date just and do add watch, and you see I still add these watches because I am dispatching an action that will be caught by my reducer here. And since my action type equals add watch, then I return my new state with my action.payload, which is my new watch here. Now, let's also add the functionality to remove a watch. So when I call my remove watch function, I now want to call the dispatch function here, and I'm going to pass an object that is going to be my action, but it is going to have a type of action type dot remove watch. And then my payload is going to be the ID of the watch that I want to remove. So now here I can do if action dot type is equal to action type dot remove watch. Then what do I want to do? Well, I want to return my prev state dot filter, and then it's going to take a watch, and we're doing just what we did before when we were setting our state. We're going to say the watch.id does not equal, well, it's not going to equal my action.payload here, because my action.payload is going to be the ID of the watch I want to remove. So we want to return our watches, filtering in the watches that have an ID that does not equal the action.payload, the watch we want to remove. So I'm calling this remove watch, and nothing needs to change down here. I still call remove watch with the ID of the watch I want to remove. So if we come back, let's add another one. Let's do Rolex Submariner again. I do indeed like that watch. You know what watch I actually really like? I like the Rolex Titanium Yacht Master. This watch was just released. If I could have this watch, I definitely would. But now we have these 4 different watches. But if I click the X, it does indeed remove the watch we want, because it dispatches the action that has the type of remove watch, and it filters our watches without the watch containing the ID that matches the action.payload. Now, the last thing we need to do here is we now need to clear our watches. So we can do if action.type is equal to action type dot clear watches. Then at this point, we can just return, we can just return an empty array here because we want to clear our state. Now, if for some instance we get through all these if checks and our action type does not exist, what we're going to do is we're actually going to throw a new error saying reducer was called with action.type that does not exist. And what we can actually do here is I can console.error, and I'll just like JSON.stringify my action. So I'll console error this action here just to see what the action was if for whatever reason we called this and we weren't able to match the action type. But now when we call clear watches here, as long as we dispatch the action with an action type of clear watches, it should clear our watches. So in clear watches, all we need to do here is dispatch an object that has a type of action type dot clear watches. And then when we do this, we can go back to our UI. And if I click clear watches, it does indeed clear my watches. So let's add some watches, and then I can remove them, clear them, and you can see our state is working correctly here. So I know the useReducer, it can be a little bit tricky, but once you get the pattern down, it's really not too hard, but there is kind of a lot of kind of boilerplate that goes into it. But once you get used to using useReducer, I think that it will make quite a bit of sense. All right, so those are the two hooks for managing state within your application. But now let's move forward into managing context. So context, it allows you to use data within a component from distant parents or children within your React component tree without needing to prop drill or lift state. So within React here, you can think about our application as a component hierarchy. So we have our page components here. So let me actually go over to my context hooks page here. So we have this page component here, but within this component, I might want to render out different components. So I might want to render out my watch list within this component. So this watch list is technically a child of this parent component of context hooks. Now, what if within my watch list, I had more components within that, and then maybe those components had components within them? So it's like this tree-like structure of parent-child relationships. But what if I had some state in this parent component here, my context hooks component, that I wanted to pass down into a bunch of my child components? So within watch list, let's say I had a component that wanted state within this context hooks. Well, I could pass that state as a prop here. You know, I could do, since I'm using like a theme constant here, I could pass a prop that, you know, theme is equal to theme. And then within my watch list, I could pass theme is equal to theme to its children, and so on and so forth. But what that is called is prop drilling. And it's generally not like the greatest thing to do. It's not like terrible by any means. Like that's how you can move state from parent to child within React. But if you need to drill down into several children, it can be a little bit tricky to know where that context is coming from and where that state is coming from. And also, so I have this state within this context hooks, but what if I wanted to have this state in sibling components? Like I wanted to have it within context hooks, but I also wanted to have it within custom hooks, within effect hooks, and I wanted to share this state across children components. Well, then I would need to lift the state up into like my root component here, this home component, and then pass that down into all of my children component, which that can also be a little bit like tricky and not the most clear thing to do. So to get around that, you can use what is called context to share across your component hierarchy without needing to kind of lift state or do that prop drilling method. Now to use context, and I'm going to remove my watch list here, but to use context, what you need to do is you first need to create a context, and then you need a provider to provide that context to your components. And once that context is created and provided, you can then use the useContext hook to consume the provided context. So for an example of this, let's go to context here, and then let's click on theme context. So what I've done here is I've created a context here. So to create a context, you can call create context that you import from React. And when you create a context, all you're doing here is you're initializing some piece of state within your application. So I'm just initializing it with null here. All right, so I'm calling create context, and that's just initializing your context or your piece of state that you want to share across your application. Now, create context, it actually returns a React component here in which it has a .provider property on this component. So you can see it returns theme context here, and that can be used as a component that has a .provider property. And this is effectively going to allow me to provide this context to all the components that want to use it. So what I'm going to do here is on my theme context.provider, I want to provide a value that I want to share across my components. So here I'm sharing a value of dark. And then I'm creating a theme provider wrapper component here. So anything that I pass into my theme provider right here, it is going to render out within or as a child of my theme context.provider. And anything you render as a child within your context, it's going to be able to access the value of that context. All right. So within my layout.js here, what I do is I render out my theme provider, and in Next.js, your root layout, it wraps your entire application. So since I pass my children here within my root layout to my theme provider, that means every single part of my application is going to be able to access the value of my theme provider context here, because I created the context right here. So first we create this context here, we initialize it with a null, but then we need to call our theme provider component, and we need to pass all of our components that will want to use our context value here, and then we can consume that context within any components that are passed in as children. And since I rendered it out within my layout here, my theme provider right here, and I passed my children here, which within Next.js, the children of your root layout is going to be all of my different components. So here, all of my components are going to be able to consume this context that I just created, and they can use this value of my context. It is a little bit tricky, but hopefully that is clear. But now to use this within my components, let me go to my context hooks in my page.jsx. The way that you can use this is actually pretty straightforward. All you do is you call the useContext hook, which you import from React, and then you pass in the context that you want to use. So here I imported my theme context. So here my theme context, I exported my const theme context. That is the return value from calling create context from React. I export that, and then I import that into the component I want to use that context. And then I pass that context into my useContext hook. And then that is going to return the value of my context. So passing in theme context to useContext is going to return this value of my context, but it's only going to return the value of my context if my component is a child of my theme context.provider, which it is because I render it within my root layout right here. So my children is going to include this context hooks page. So now that I've passed in my theme context here to my context hooks page, and I just console log my theme, if I open my console here and I refresh my context hooks page, what I should see is a theme of dark, because my theme context has the value of dark. And I'm passing in my theme context to useContext and console logging that here. Now, if I change my theme to be a light theme, you see my theme is now light. So that allows me to use this state within any component within my application. So here we use it within context hooks, but I can also use this within state hooks. So I can say const theme is equal to useContext, and I import useContext from React. And then here I do need to make sure that this is a client component, so I'm going to do that real quick. You don't need to worry about this too much. That's Next.js specific. But here I'm going to use context, and then I'm going to import my theme context and pass that in here. And then here within my state hooks page, if I console log, I'm going to say state hooks theme context. I'm going to set that to my theme value. And if I come back and I go to state hooks here and I check my console, I see my state hooks theme context is light. And if I come back and if I go to my theme context and I change it back to dark, you should see that the value is now state hooks theme context is dark. So I'm able to use this context within any of my pages across my application because I create the context and then I call the useContext hook within my app. So useContext is a hook that allows you to share context across your application. Moving on to ref hooks here. So first off, what even is a ref? Well, refs allow you to maintain information that isn't used for rendering UI or rendering your user interface, what the user actually sees. For example, refs might be used to maintain reference to a DOM element, or you might store a timeout ID in a ref or something similar to that. Now, you might be thinking to yourself, what is the difference between a ref and a piece of state? Like, both of them store information and allow you to preserve data across re-renders of your components. Well, the primary difference between state and refs is that when a value of a ref is updated, it does not trigger a re-render of your component. Whereas with state, when state changes, since you're displaying state to your user interface, it's information that the user sees that changes over time. And when that changes, it triggers a re-render of your component. And you want that. You want it to re-render your component because you want your information to your user to update. Well, a ref, it doesn't trigger this update. It doesn't trigger a re-render when the ref is updated. A ref is also different from a regular variable since variables reset on every render, whereas refs are maintained. And refs are useful when you need to do non-React stuff like working with browser APIs or external libraries requiring refs, or like I said here, if you're wanting reference to a DOM element and just persist that across renders. Now, one thing to note, like I said earlier, do not use refs for displaying user interface. If you're going to be using information to display UI, then you want to use state. And like I said, the reason why is because state, when that updates, it will re-render and that new state will be shown to your user. But for a ref, if you update your ref value, that doesn't update to the user, which is probably not what you want if you're rendering UI. Also, it's best to update the values of your refs in event handlers, not in the body of your component. So let's go look at an example of this. Let's head back to VS Code here. And on my refs hook page, we're going to go to my input ref component. So I'm going to open this up. And the way that you can use refs in React is first you need to import useRef from React, a custom hook called useRef. And then to use this, very similar to all of your other React hooks, you call this at the top level of your function. And when calling useRef, you can initialize it with an initial value here. So I'm just initializing this with null, but this could be some other value. But it's going to return an object, and this object is going to have a .current property. And this current property is going to be the value of your ref. And then if I want to use this to maintain reference on a DOM element, I can set for my element here, just like what I'm doing here for my input, I'm setting ref is equal to my input ref. So on the .current property of this input ref, that is going to be this input element right here. And for this example, we are calling useRef, initializing it to null, but then we're setting our input ref to our input ref. So this input ref is going to maintain reference to this input. And then when I click focus, this onClick function, it is going to call input ref, accessing the DOM element, so .current. Remember, this can be kind of messed up by some people. Your ref, it returns an object. which your reference is going to be on the .current property of the object returned by useRef. So since we're making this input ref, we're maintaining reference with it with this input ref reference returned from useRef. When we click this focus button, we can call inputRef.current.focus, and then I just console log my input ref right here. So let's head back to our example here. I'm going to open my console, and what you can see here is I console logged an object, and this object, you can see it has a .current property, and this current property is maintaining reference to my input element here. And it has a value of just empty string. But if I type into this element here, you see it doesn't update my ref here, because just because I updated my input doesn't mean that my ref value is going to change and update or trigger a re-render. So since it didn't trigger a re-render, I have nothing else rendered in my console here when I type into this value. So that is one of those big differences between refs and state. But now I'm going to clear my input, and I'm going to unfocus my input, but then I'm going to click focus here. And you can see this does indeed focus my input when I click focus, because we're maintaining reference to this input element. When I call focus, it is calling inputRef.current.focus. So refs allow you to maintain information that isn't used for rendering user interface, and this can be useful for maintaining reference to a DOM element like I just showed you, or a timeout, or like external libraries or different things like that. But just know that when using a ref, it doesn't trigger a re-render when it updates. And another catch with refs is that when calling the useRef, you can initialize it with any value, but this returns an object in which it's going to have a current property, which is going to be the value of your ref. All right, so that is using references and the useRef hook in React here. But now let's move over to effect hooks. So this one here, it can be a little bit tricky, in which I think it's one of the hardest to understand hooks on like the rendering cycle and the life cycle of this hook. But as you gain experience with it, it'll become much more clear here. So React provides a few different hooks for having side effects in your apps. And side effects would be things like making network requests, manipulating the DOM, working with browser APIs, animations, or any other kind of non-React code. So a side effect is when you influence some external world outside of your specific React component. So network requests, browser APIs, animations, manipulating the DOM, stuff like that. And the hooks that React provides to perform these side effects include useEffect, useLayoutEffect, and useInsertionEffect. Now, I think that you really only, for the most part, are going to be using useEffect, but you still might use useLayoutEffect if you need to perform an effect before the browser repaints the screen, and you might use useInsertionEffect if you need an effect before React makes changes to the DOM. Now, we're going to just cover useEffect, but the main difference between these three different hooks here are when they are initially called. So useEffect is going to be initially called when your component first mounts, but useLayoutEffect is going to be called before the browser repaints the screen, so a little bit before useEffect. And then the useInsertionEffect is going to be called before React makes changes to the DOM. All right, so there's kind of three different layers of when these are initially called. I would just say, for the most part, you can default to using useEffect, but if you find that you need to perform some action before useEffect is called, then you can look into using useLayoutEffect or useInsertionEffect. Now, useEffect can be quite complex, and generally speaking, I'd recommend not using it if you can get away with it. And especially now, since Next.js offers server components, and I think that a lot of meta frameworks are also kind of thinking server first, or, in Quick, you have resumability and different things like that. So I think that generally, more and more often, you can get away with not having to use useEffects, but it's still, I think, good to understand. So let's go look at an example of how this works here. So I'm going to head to my useEffect hooks page, and we're going to open the useEffect example right here. And as you can see, I'm importing useEffect as well as useState from React here. And all we're going to do is set up a counter. And we're going to do this using useEffect. So we already went over useState, so this should be clear what's going on here. But for my useEffect hook, what's going on here is useEffect hook is going to take two arguments. The first argument of the useEffect hook is going to be a function. So right here, I'm passing an inline function as the first argument to useEffect. And this function is going to be called once this component initially mounts. So within the body of this function, it's going to run when this component initially mounts. Now, the second argument to the useEffect hook is going to be a dependency array. And what this means is that if you put in an empty array, it means this function passed into useEffect is only going to run when this useEffect example component initially mounts, or whatever component initially mounts. It's just going to run on that first mount, and that's the only time it's going to run. However, if I didn't put an array at all here, and I just didn't pass a second argument, then this useEffect hook is going to run on every single re-render of this component, which generally speaking is probably not what you want. So I would avoid doing that for the most part. All right, so no array or no second argument is going to be runs on every re-render. An empty array is just going to be on mount, but we can also put in different values to this dependency array. And what React is going to do, it's going to check, okay, if that value changes, then it's going to rerun this effect. So you want to put values in here that your effect depends on, hence dependency array. So let's say you want to run this function within your useEffect every time a certain piece of state changes. Well, then you would put that piece of state in this array. So, we would put count in this array, like this piece of state here. Or if we were relying on a certain, say we were making a network request here, and it relies on the, say, user ID, and we wanted to run that network request every time that user ID changes, then we would place that user ID in our dependency array, because we want this passed in a first argument function to run every time this user ID changes. And you can put multiple dependencies in this array. So anytime a value in this second argument, this dependency array changes, it's going to rerun the function passed in to useEffect. But if you pass in an empty array, it's just going to run useEffect when this component first mounts. And if you don't pass anything, it's going to rerun it on every re-render of this component. But I generally don't see a lot of situations to where you're going to do that, if any situations. I'm going to uncomment out this. And what we're doing here is, when this component first mounts, because I'm just passing an empty array here, we are setting an interval within my passed in function in which I'm just going to increment this count piece of state by 1 every second. But you're also going to see that from this passed in function to useEffect, I also return a function. So I'm returning this anonymous function here in which I clear this interval. And what this is doing is, when you return a function from your passed in function as your first argument to useEffect, that is going to run this returned function when this component unmounts. So if I leave this page that mounts this useEffect example and I unmount this component, I remove it from my page, it's going to run this function here returned as the first argument to useEffect on this unmount, and it would effectively clear my interval. So if you need within your effects to clean them up when that component unmounts, then you return a function from your passed in function to useEffect to perform your cleanup, because it's going to run this function when this component unmounts. So on mount, I'm starting this counter, and then when this component unmounts, I'm clearing my interval to effectively clear my counter. So if we come back to my page here, you can see it is indeed incrementing my count here. And let's actually go ahead, and when I return this clear interval, I am also within the body of this returned function. All I'm going to do is I'm going to console.log clearing interval. So we can see this run when I unmount this component. So currently we have our counter incrementing because on mount, I'm just setting this interval to increment this count every second. But if I open my console, and I'm going to just clear my console here, and let's go to my ref hooks page, you can see I get clearing interval, because when I leave my effects hooks page, it's effectively going to unmount, and when it unmounts, it's going to clear this interval so it doesn't result in like a memory or performance leak in my application. Now, what happens here when we put the count in our dependency array? So let's actually go back to our browser. Let's go back to our effect hooks, and we see our count. Since I remounted this component, it's going to start incrementing again. But now let's put our count in the dependency array. I'm going to remove clearing interval here. But what I also want to do is I'm just going to console log the string running. So I put my count in my dependency array, which means that this function, it should run every single time my count changes. So really every second this should run. So now if I come back and I'm going to refresh my browser here, but I see running, and it's running this function every second, because every second I update my count, and when my count updates, since it's in my dependency array, it reruns this function. So now instead of just running this function on mount, it's running every second. So now let me remove my count here, and then I'm going to come back, and then I'm going to delete this, and I'm just going to refresh my page here. And we see it runs initially when this component first mounts, but it doesn't keep running my useEffect because my count is no longer in my dependency array, and it only runs this on mount. So here you can see that you have to be pretty dang careful with your dependency array, because often you don't want to keep running this function continuously when a piece of state changes, but sometimes you do. So you really have to put thought in when you want this passed in function to run and control it with this dependency array, which is what can really make this a tricky hook to use. But hopefully this gives you a good idea on how this useEffect hook works. So let's keep moving forward here, and let's now look into performance hooks. So for our performance hooks, and you can see I console log, hey, a lot of times here in my browser, because it's loading my performance hooks page, which we will talk about for optimizing performance, because we don't want this to be happening too much. So let's take a step back here and let's get into the performance hook. So sometimes React can re-render quite often, leading to performance issues. However, before doing these optimizations, so when it comes to these performance hooks that we're going to talk about, before optimizing in these ways, I would highly recommend to actually make sure that you have re-rendering issues, because like React, the way it's built to re-render quite a bit, because that allows for these dynamic state changes for your user to see. Your re-rendering isn't always an issue, and it doesn't always cause performance issues, but sometimes it does. So sometimes you do need to use these hooks, but I would just make sure that you're optimizing the big stuff first, like, you know, not waterfalling your network requests or having memory leaks or like different stuff like that. Now, if you do find you need to optimize performance, you can do so by using useMemo to cache the result of an expensive calculation. So to This is also called memoizing the expensive calculation, or by using useCallback, which is basically caching a function before passing it down to optimize your different components. And caching is just saving the return value of doing some work and reusing that value so you don't have to keep doing that work over and over again. So this might not be totally clear right now for useMemo and useCallback, so let's dive into it a little bit further here. So useMemo, it accepts two arguments: a function that does some work to compute a value, and a dependency array, just like what we talked about for the useEffect hook. Now, React will call the passed-in function once on the initial render, and it will store the returned value. It will then only call the passed-in function again if a value in the dependency array changes. So let's head back to VS Code here. Let's go to my performance hooks page. Let's open up this useMemo example. So what we had going on earlier is we were seeing hey being console logged a ton because I have this function that is just a representative of doing some expensive work in our application. And this could be like network requests. It could be, performing certain calculations. It could be looping over, doing like a or space-time complexity calculation, any of those things. In our case, we just loop from 0 to 100,000 and we console log whatever text is passed into this function. And then we return the text. And in this example, we wouldn't want to rerun this function on every single re-render of our component. That would get quite unwieldy in our application and would result in very poor performance. So to fix this, we can use useMemo. Like I said earlier, useMemo is used to cache the result of a certain function. So in this instance, we're passing in an inline function to useMemo as the first argument, and we're calling expensive work with this text here, the text of hey. And the second argument to useMemo is going to be a dependency array. And we pass our variable text, which is hey. So what we're doing here is we're saying, okay, React, whatever a value is returned from our passed-in function to useMemo, and in this instance, we're passing in an inline function that returns the return value of expensive work. So just hey here, we're saying, I want you to store that return value of this passed-in function, and I only want you to call this function again when our text changes. And this will prevent React from needing to call this function on every single re-render. So by using useMemo here, it prevents us from needing to continuously call this expensive work function on every single re-render, which we would be doing if we called const text value is equal to expensive work text. We would call this and initialize this value on every single re-render of this component, which is definitely not what we want here. All right, so useMemo, you also have to keep in mind that dependency array on when you want to rerun this initial function, but hopefully that is clear what's going on here. Now with that, you can also do a very similar thing with useCallback, and it works in a very similar way to useMemo. However, instead of caching a return value of a function, it caches a function itself. The first argument to useCallback is the function you want to cache, and the second argument is a dependency array. React will return the cached function on initial render, and will only reinitialize this function when the props change. This can particularly be useful when using a function as a dependency or a prop. So in React, when a component's props change, it re-renders that component. And if you pass in a function to that component, well, functions are reinitialized on every re-render. So that's going to be a new value, which is going to re-render your component that you're passing that function to. And sometimes this isn't an issue, but often you don't want to just re-render a child component just because you're passing a function to it on every re-render. So to get around this, you can cache that function using the useCallback hook. And this should actually be useCallback example. So we're gonna import useCallback example from components useCallback example. So now if I go into useCallback example, the way that this works is very similar to useMemo, and this should also be called useCallback example. But the way that this works is very similar to useMemo, in which we import useCallback from React. And when we call useCallback, the first argument is going to be the function that we want to cache. So here, expensive work, this is the function we want to cache. And then the second argument is going to be dependency array of when we want to reinitialize this function. So here we want to reinitialize this function every time our text changes. If we passed an empty array, it would just initialize this function on the initial render of this component, and it would never reinitialize this function again. And if we didn't pass any array, it would reinitialize this function on every re-render, removing the purpose of using useCallback altogether. So this is the very same way that useMemo works here. So this is saying re-render this pass-in function or reinitialize this passed-in function every time that this text changes. And then the return value of useCallback is going to be your cached or memoized function. So it's going to return a function here instead of just returning the return value of calling this function. It caches this expensive work function and it returns it here. So if we want to use this expensive work function, we can just call the return value of useCallback, calling memoized function. And this allows us to cache this first argument to useCallback, this function, and then this would allow us to safely pass this as a prop to different components because we're not reinitializing this function on every re-render. We're only going to reinitialize this function when a value of this dependency array changes. All right, so this works very similar to useMemo, and the main difference is that it caches a function instead of a value or the return value of a function, because in JavaScript, technically, functions are values because you can pass them around as like first-class citizens and stuff. But the main purpose that I see for this is if you ever need to use a function as a dependency of an dependency array or as a prop to a component, but you don't want to reinitialize that function on every re-render, triggering your dependency array to run on every single re-render, as well as re-rendering your components you're passing that function as a prop to, then you want to use useCallback so you don't reinitialize that function, and you only reinitialize that function when a value of your dependency array changes. So that is useMemo and useCallback, two hooks that can be useful for optimizing performance. And the main difference between useMemo and useCallback is useMemo, it is used to cache the return value of a function, and then useCallback is used to cache a function itself. And that can be particularly useful if you need to pass a function as props or as a dependency to a dependency array. And both of them have very similar APIs. So hopefully that is clear. But the final thing that we have to go over here is creating custom hooks. So you aren't just limited to the built-in hooks provided by React. So you're not just limited to useMemo, useCallback, useEffect, useRef, useContext, useState, useReducer. You can also create your own custom hooks. And you can do this when you want to reuse some React logic throughout your application. So you would create a custom hook for the same reasons that you would create a JavaScript function, just to reuse some logic. But you would create a custom hook instead of just a JavaScript function when you want to reuse some specific React logic. And your custom hooks still need to abide by the rules of hooks, calling them at the top level and only from a React component or another hook. And they must also start with the prefix of use. And custom hooks help you share stateful logic or effects, but not state itself. So this is an important distinction. Custom hooks, they often just wrap around other React hooks. So let's say that you want to create a custom hook, which we will in a second, that uses local storage. Well, since we're using that browser API, that's a side effect. So we might need to use the useEffect hook to use that local storage, or we might need to use some React state to use that local storage. So we might create a custom hook, which we are going to do in a second, that is use local storage. And that's going to wrap around maybe useEffect and useState and allow us to kind of reuse that logic across our app. But we're not necessarily sharing state itself across our app. When we want to share state across our app, we can use something like Context or some other state management provider. However, keep in mind that some duplication isn't bad, and just because you can create a custom hook doesn't mean you necessarily should for every single little thing. So in the example that we're going to use here, so in my custom hooks page, what I'm going to do is I'm going to use a custom hook that I've created called use browser storage, and I call it use browser storage within my component, but here the file is actually called use local storage, and then I call it use browser storage here. So I meant to title this file use browser storage. So if you're seeing this, the file is going to say use local storage, but I intended for this to say use browser storage. That is my mistake there, but I didn't realize this until I'm already an hour and a half into this tutorial. So just bear in mind that I meant to call this use browser storage for the file name, but the point is going to remain the same here for this custom hook. So to create this custom hook, I just create a JavaScript function here that starts with the prefix use. And within this custom hook, I'm taking one argument here, which is going to be storage type. So I'm defaulting my storage type to local storage. And throughout this custom hook, what I'm doing is I'm setting up a piece of state here. So error and set error is equal to useState. So if an error occurs while I'm trying to use my local storage, then I'm going to set that error. And then I'm setting a constant of storage to window dot whatever storage type I want to use. So either local storage or session storage. So this value here is going to be either local or session storage because it's going to be window dot local storage if I pass in local storage, or session storage if I pass in session storage. And then I have a few different helper functions here. So I have a get item function in which it's going to accept a key and it's going to try to get an item from either session or local storage. And if there's an error, it is going to catch that error. And then I have a set item function that is going to take a key and a value, and it's going to set an item to either local or session storage. Then if there's an error, it's going to catch that error. And then I'm also going to have a remove item function that is just going to remove an item based on a key from storage. And from this custom hook, I'm returning get item, set item, remove item, and error. So to use this within my components, I can use this just like I've been using any other hook throughout my application. So let's go to this custom hooks page. And in my custom hooks page, I call my use browser storage. I don't pass it an argument, so it defaults to local storage. And then I return get item, set item, remove item, and error from use browser storage. Because when I call this hook, it returned get item, set item, remove item, and error as an object. So I'm just destructuring those within this custom hooks page. And then when this component mounts, I use a useEffect hook to set an item to local storage with a key of example and a value of 1, 2, 3, so on and so forth. And then if I say there's an error, I just return null. I don't render this component. So if I come back to my browser and I inspect and I make this a little bit bigger here and I go to application, and then I dive into local storage here, localhost 3000, we should see I have a value of key example and then value of the value that I set, because I set this to local storage using my custom hook. But now, what if I want to read this item from a different page? So let's go ahead and I'm going to How about from context hooks? I'm going to actually just remove this, but I'm going to say const get item is equal to use browser storage. And then I'm going to say const example is equal to get item. And then I'm going to get my key of example, and then I'm going to console log my example. So now if I go to my context hooks page and I go to my console, you see I have console logged my value of local storage with the key of example, which is 1232345, which is what I set to local storage in my custom hooks page. So you can see I can use this custom hook throughout different pages of my application because I'm reusing this logic here from within this hook. And then if I wanted to use session storage instead, what I can do is I can, within my custom hooks page, I can pass in session here to use session storage. Actually, I need to pass in session storage. And then this is going to set an item to session storage. And then when I come to my context hooks page, I also need to use session storage. So I'm reading from session storage. And then if I come back and I go to custom hooks and I clear this and I refresh this and I remount, I should be able to go to application, and then I'm going to go to session storage. And then you see I now set this value within session storage. And then if I go back to my console and I go to context hooks, I see I console log this still because I'm using session storage. By using this custom hook, it allows me to use it across my application and reuse that React logic everywhere that I need to use it, just by importing it and then using it just like all the hooks that we've been using earlier. So these custom hooks can be very useful for creating your own hooks and reusing that logic throughout your app. I think there are also websites of various custom hooks that you can use in React. So you can, just do that, or you can ask ChatGPT to create a custom hook for you if you're finding yourself needing to reuse a lot of logic. But just keep in mind that, you shouldn't always just be creating a bunch of custom hooks for every little thing. There is a balance there between allowing for some duplication to occur, but also creating a custom hook when it's needed if you're reusing a lot of the same kind of React logic throughout your application. So thank you so much for tuning into this. We have covered a lot about hooks, what hooks are, state hooks, context hook, ref hooks, effect hooks, performance hooks, custom hooks. Hopefully you've learned a ton from this video. Thank you so much for checking it out, and I'll see you in that next one.